What's up, guys? My name is Ryan. I'm a tutor in the Econ Tutoring Center. Today I'm going to talk and show you how you can derive a cost function, C as a function of Q, from a production function, F of LK. Remember that the language and notation that we use may vary from your professors, so always check to make sure that the language we're using is the same as yours. Okay, so we're going to show you how you can derive a cost function from a production function. So we're going to define this problem, which is called our cost minimization problem. And we know what our general cost function is. We have our C of L and K. I'm going to say that I'm going to kind of fix the price of labor and the price of capital to be 1, just so that things are easy. So that's just equal to the price of labor times how much labor we have, plus the price of capital times how much capital we have, right? And we want to try and minimize this subject to some fixed level of output, right, which is given by f of LK, right? And I'm going to go ahead and come up with a production function, just a nice Cobb-Douglas, L to the 1/2, K to the 1/2 equals some fixed quantity Q. So I'll erase this so that you see this is a little bit separate here. This is, we fix PL and PK to be 1. So I'll draw a quick graph for you just to show you what that looks like. That is really saying we're fixing some isoquant from this, which is fixing Q, which might look like this here. That's our qth isoquant. And then we're going to have a bunch of these lines, these isocosts, right? We might have a bunch of parallel lines like this, right? And we're trying to find the one that most efficiently produces Q, right? So the farther out you go on these isocosts out here, the higher your costs get. So the smallest isocost we have that touches this quantity level right here is where it's just tangent right there. So this is the isocost, and that's the efficient level of labor and capital, the cost minimizing level of labor and capital to produce Q units of output. So you can find some of this intuition in other videos or come into the tutoring center. But basically I'm going to show you mathematically how to solve for this, what we would call L star and K star from our cost minimization problem. And then doing that, we're going to be able to define L and K as a function of Q and eventually get cost as a function of Q, which is our cost function. Okay, so the way we do this is, remember, we found that tangency there. So we're going to set the slope of the isoquant equal to the slope of the isocost function here, right? So we take, remember, the slope of this isoquant here is called the marginal rate of technical substitution, right? And that's actually given by the derivative of our production function with respect to labor divided by the derivative of our production function with respect to capital. So it's the ratio of the marginal product of labor and the marginal product of capital. And our equilibrium condition, or rather our cost minimizing condition, is that this is equal to the slope of the isoquant, which is the price of labor, over the price of capital, really the negative that. Excuse me, this is the slope of the isocost, this is the slope of the isoquant. And that gives us this tangency condition here. So, well, we know this is K and this is 1 over 1, and we can just solve for this right now. So taking the derivative of F with respect to L, we get, let's see, that's going to, I'm going to move the 1/2 down on the L, and I'm going to be left with L to the negative 1/2, K to the 1/2. And then I take the derivative of F with respect to K, and that's going to get me, again, 1/2 L to the 1/2, K to the negative 1/2. I can move these, the 1/2s will cancel, and I can move the negative powers up and down respectively. So I move the K to the negative 1/2 to the top, and I get just K on top. And same thing with L, I move to the bottom, and I get L. So K over L. And then I set that equal to, I set K over L equal to our price ratio here, which is 1 over 1, so equals 1. And that's going to get me that K equals L. And this is our condition for any any quantity, right, the cost minimizing level of producing that quantity is where K equals L. So we'll move to a new page here and use this fact to find K and L as a function of Q. Okay, so remember our production function is f of Lk equals K to the 1/2 L to the 1/2. I wrote it the other way last time, but this will be fine too. And that's any given level of quantity. And remember from the last, and I'll also write out our cost function, C of Lk equals, remember PL, PK equal 1. So this is just going to be the amount of labor we have plus the amount of capital we have, right? And from the last, from the cost minimization problem, we found the optimality condition is that L equals K, right? So now I can plug this into our production function, and I'm going to be able to find L and K as a function of Q, right? So remember, now if I plug in L equals K here, I'm going to get L to the 1/2 times L to the 1/2 equals Q. These have the same base, so I can just add the power. So that means that L equals Q. L also equals K, so this also equals K here. Right? So now this will give us a simplification here for our cost function, because we can plug in L equals Q and K equals Q to this cost function, and that's going to get us that C of Q is equal to L, which is Q, plus K, which is also Q, which equals 2Q, which is our cost function. So this is a simple example of how you can use this cost minimization problem to find your cost function, given your production function and given the price of labor and capital. By the way, in some classes they may refer to PL as W, wage, and PK as R, the rental rate. So that's just one thing to look out for if you use a little bit different notation, but it's all the same problem. It's all trying to minimize this cost subject to this, and then we're able to substitute and find our cost function. So hopefully that gave you a better idea of how production functions like this are related to cost functions. If you have any more questions, come see us in the Econ Tutoring Center.